For today's class, we're going to be working on proofs. Now, I'm not going to walk you through every step of a proof, but I'm going to help you in creating a plan for proof. A plan for proof kind of goes through what is the logic and what order do I need to reveal new information as I create my proof. So the first are two questions that I always ask myself whenever I'm starting a proof. And the first question is, what does the given imply? So here we're given that PQRT is a rhombus. That implies a lot of information. So for instance, the most defining feature of a rhombus is that it has four congruent sides. But we also know that because this is a parallelogram, opposite angles are congruent, and opposite sides are parallel. It might also be useful to know that diagonals of a rhombus are perpendicular, meaning we have a lot of right angles in the middle. This gives us a wide variety of information that will help us to target our proof. Our end goal is to show that PR bisects TPQ and QRT, which are the two opposite angles. We also need to show that the other diagonal, TQ, bisects its two angles. So we might need to use parts of the shape to create our proof. So that's our question number 2. Can we use parts of the shape? And in this section, what that question is telling me is what are different ways that I could break up this shape into other shapes that I know more information about. So for instance, I could break this shape into two isosceles triangles. I could either do that by splitting it by PR, or I could split it using TQ. Well, those are the diagonals that I'm talking about. So isosceles triangles was my method when creating a proof for this problem. By using the isosceles triangles, I was able to show that the base angles are congruent to each other. And since the base angles are congruent and the sides are congruent, you can show that the two triangles are congruent. So triangles are congruent. Well, congruent parts of congruent triangles are also congruent. But a proof can be done in a number of different ways. Maybe you wanted to use the property that diagonals are perpendicular, and you wanted to treat these as right triangles. That's another strategy. I think it would be a little bit longer than using isosceles triangles, so just try to find an efficient pathway, but as long as it's valid, you have a number of different ways to prove any piece of information. Additionally, we're going to be working with parallelograms a lot. You may want to think about how we might use parallel lines cut by a transversal. Now you have a lot of choices here. Always go back to what you are proving and maybe draw in that piece of information on your diagram and see which part of the shape does it really lend itself to. So here, the angles that I was looking for were parts of the isosceles triangles, and so that's why I went with the isosceles triangles instead of one of the other two strategies. Here we're given two parallelograms that are attached at point C. What does the given imply? Well, we can gather a lot of information from the fact that these are parallelograms. For instance, opposite sides are congruent, opposite angles are congruent, and opposite sides are parallel. Another important fact here, because they share the point C, and BF and GD appear to be collinear, we have two vertical angles. So in the middle, BCG and DCF are congruent angles because they are vertical angles. So if I'm trying to get A to show that it's congruent to E, well, those are both opposite angles to the vertical angles. And that would be an important thing to use. You might need to also include the transitive property. So if A is congruent to C and C is congruent to E, then A is congruent to E. Last, I'm going to give you a challenge problem, and this is what we're going to start our class with. So please tackle this problem independently, do your best. but I'm curious to see what you come up with. Here we're given AC and BD are two line segments. They intersect each other at point N. So right now, draw two line segments and label them AC, BD, and the intersection point should be labeled N. Be ready to do a little erasing because you're going to have to make it fit the other information as well. So AN is congruent to BN. Draw a congruent mark for those two segments. CN is congruent to DN, so draw a different congruent mark, so like two markings for those. AC and BC do not bisect each other. So AC is not congruent to BC. So make sure that they don't look like they're the same length. I'm curious to see what quadrilateral you think this is. Bring your guess to class, and that's how we're going to start things off.